Welcome everyone. Today we will draw the cross section along line A dash B dash for this map. We already have done this exercise along AB line. So along AB line, because we were not getting this fault, so rather than choosing one section line, we are taking one more, that is second section line on the same map. So we did this map as 13A earlier, and now we will rename this map as 13B for the section line along A dash and B dash. So we already have interpreted this map that there are 1, 2, 3 and 4 beds present in the older sequence, and there are 2 beds in the younger sequence, and older and younger sequence are separated by a plane of erosion and non-deposition, that is a angular unconformity. So we have one angular unconformity in this region, and the younger sequence contains 2 beds, the first and second bed. The younger sequence belongs to Carboniferous age. The first bed of younger sequence is limestone and second is sandstone. In older sequence, the first bed is conglomerate, second bed is grit, third bed is mudstone, that is represented by yellow symbol, and then we have fourth bed, that is the youngest one, this is shale, and the older sequence belongs to Silurian age. So now we have determined the cross section, and we have drawn the cross section and profile along this line. So for that, what we did, we determined the strike and dip directions of older sequence and younger sequence. So this is the dip direction for older sequence from A to B, and we determined the apparent dip along the section line. So if this was the section line, we determined the apparent dip and we took this HE to draw the section along this line. Now because our section direction has been changed, it means our dip amount will also be changed, because apart from true dip, there are enormous possibilities of apparent dips. In the strike direction, the apparent dip is 0, in true dip direction it is maximum. In other directions it varies from 0 to maximum values. So for our older sequence, now the HE will have a new value, that is this one, because this is section line, so HE lies on the section line, so this will be HE. So our dip will be different. Of course the dip direction is not going to change, true dip direction will be same, and then we will determine the dip for younger sequence in this direction as well. So this will be HE for the younger sequence. Now let's determine the dip. First we are going to measure the HE. For that we are going to use this. So let's first determine for the older sequence. So these are 2 strike lines on the older sequence. One is this one, another is this one. Let's determine it. This much is the amount. So if we draw it here, and draw 0.1 inch over it. This will give us the value of theta, that is apparent dip in direction A dash B dash. So here we can see the new dip or apparent dip in A dash B dash direction for the older sequence is 5 degree. let's see the tip for younger sequence as well. For that we will have to measure the HE, because this is a strike line for the older sequence and this is a strike line for the younger sequence. We will have to measure this distance along the direction of our section line. So here we have measured. Now we can draw it somewhere. Then 0.1 inch over it. This is 0.1 inch. Now join another of end of H to CI. So here, after joining this, we can measure this angle. So now we can see that the apparent dip for HE for the younger sequence is roughly 3 degree in this case. Three to 3.5, 3.5 degree. So let's now draw this section and compare the section which we have drawn in direction A dash AB to the direction A dash B dash. So this is earlier section we have drawn along line AB. This section is along this line, and now we will draw this section. So here is our A dash and here is B dash. Then let's mark the values of contours in order to draw the heights. Let's mark these values. This is 500. I'm writing only 5 for 500. Here is a 400, 500, 600, 700, back again. We got 700 over here as well. So this is 700. This is 600 and this is 500. Now after drawing that, we will draw the beds. Let's position the beds as well. So this particular line is intersecting our section line over here and here. So these will be the traces of bed. Here we will get the fault trace, and here again we will get the traces of beds. Let's start this. So here is a bed. We will appropriately write B for the bed, and we will remove that further. Here we have another bed. Here we have fault. And then we have one trace just coinciding to our 400 value of contour. And then we have here one more trace of bed, and then we have one bedding trace over here. Let's draw the profile. So in order to draw the profile, first what we do, we draw the baseline. By joining the points A and B. So here is our point B, and here is point A. Right. So once we have drawn the points A and B, we will draw the heights. Since the contour values are ranging from roughly 400 to 800, or in fact yes, so it is ranging from 400 to 800, so up to 1000 value will be sufficient for us. Point 1, point 2, point 3, point 4, point 5, point 6, point 7, point 8, point 9. This is 1000, and this side as well. So let's mark these values. This is 0 feet, this is 100 feet, this is 200 feet, 300. I'm writing the first initials first. 400, 500, 600, 7, 8, 9, and this is 1000. 900, 800, 700, 600, 500, 400, 300, 200, 100. So we'll have to draw these values in this side as well. Here is our 1000, 500, this is 900, 800, 700, this is 600, this is 400, 300, this is 200, and this is 100. Let's write it down. 0, but this will be 200. This 3, 4, 5, 6, 7. This is 700. We have 500. Side we have 500 back. And this is 900. So now let's project the value of contours and draw the profile. So what here we have is 500. Here we have 600. Then we have 700. We have 600. $500. Then we have 600. Then we have 600 over here as well. This is 500, 600. Then we have got 700 at two places, here and here. Then we have got 600 back again here. Then we have got 500 over here. Then we got 400. This 400, and this again is 400. So let's try it. Rather than 600, this is 400 over this place, and here as well. This is 400. Then we got one more value over here, that is 500. Now by joining these points smoothly, we will get the profile. So here the variations are like 500, next one must have been the 400, and here the variation at this side, this is 400, this is 500, next one will be 600. So these points will join in between 400 and 500 in this direction. So this is 5. This will go in between 5 and 600. So this is our profile for the section line A dash B dash. So if you start walking from A dash, you are going to encounter increasing height up to this point. The maximum height will be 700, then it will again decrease to 400, then it will again increase. So this is how the profile will look like from A dash to B dash. Then we need to draw the position of beds onto the profile. Let's draw them as well. So this one is the fault. Here is the fault. Let's draw the fault first. It's a vertical fault. So this is fault. Now let's draw the beds. Oh, I've drawn the fault at wrong place. Here is the point for the fault. Above the profile, we mark any feature by dissected lines because the feature has been eroded. Now let's draw the position of beds as well. So here we have got the location of one bed, and here we have got another bed. This is a bed. This is a bed. Now one bed over here. Then we have got one trace of bed at this point. And one trace at this point. this is very heavy. So now let's differentiate which one is younger and which one is older and draw with deduced amount of tips for older and younger bits. For older we have determined it's 5 degree and for younger we have determined it's 3.5 degree. So let's see the directions. The dip is from, for older bit it is from A dash to B dash, and for younger sequence this is again from A dash to B dash. Now let's draw that. The amounts are different. So here is a fault and here we have the trace for the younger bit. We are not getting the trace for the first bit in younger sequence. Right? So let's draw them. This is 700 and this is 600. So the dip is from B dash to A dash for younger sequence, and for older one this is 7 and this is 6, so dip is from A dash to B dash only. So let's draw the amount lines for younger bit. That is from B dash to A dash, and amount is 3.5 degree. So this is the amount, and now let's join these 2 points we are getting are of the same bit. So if our amount is correct, they are going to join. Luckily we can see they are perfectly aligned. It means we have perfectly drawn our profile. So this is the second bit for the younger sequence. We need to draw the first bit as well, and that is coming below the unconformity. It is not coming over the profile, so obviously it will draw somewhere below the profile. Let's try to determine the thickness of this bit, the first bit. So here is first profile, and here is second profile. So if we see the difference, this is 600, this is 700, and here the value of this strike line is 700, the value of this strike line is 600, and if we see the difference between the two traces of the older bit, so this is the first trace for the younger one, and this is second trace for the younger one. So this is 700, this value is 700, and here it is intersecting on second trace on 800. So we can come to know that thickness of this bed is 100 feet vertically. So vertical thickness is 100. If we draw just below this, we increase these lines onto the fault, and measure 0.1 inch vertically from here. We have determined the thickness of first bed of younger sequence, so that will give us the position of this bed as well, and this is not going to come onto the profile in this direction. So this is our plane of unconformity. This will be our first bed. Now whatever bed we have to draw, we will draw below this. So let's see whether we are getting any of the bed in this direction. From A dash to B dash, we are not getting any of the older sequence bed. Now let's see in another block. So here we are getting in this block, one is over here, one is over here, and one is over here, and we have already determined the thickness of, so we are getting the trace for bed 3, we are getting trace for bed 2, we are getting trace for bed 4, we are not getting the trace for bed 1. So we will have to determine the thickness of bed 2 in order to get the bed number 1 just below. So let's try to determine this value over here. So here is one trace, here is another trace. So if we draw two strike lines for that, we can come to know the position of bed 2. So let's first draw the beds which are already present by taking the dip direction. This is 5 degree and the dip direction is from higher value of strike line to lower, and this is 600, this is 700. So from A dash to B dash. So the dip amount is 5 degree and the dip direction from A dash to B dash. Let's mark this angle. So here angle 5 degree. Let's join it. Now parallel to this will be our beds of older sequence. One bed is over here, that is our bed number 4. Then we have bed 3, this position from here to here. We join, we are getting the same trace, it is not present over here. Then the trace of bed 2. Let's see. Here is 4. Here is 3. Just below the 3 we will get the bed number 2. So because we are getting this trace for very smaller distance from here to here, Let's draw it carefully. So here is our vector. So parallel to this, draw bed 3, and just parallel to that we'll have bed number 2. So here we got the bed number 2 and here we have bed number 1. Then again we are getting the bed 2 from this position to this position, and here we are getting the in this bed, and this will extend to fall down this direction like this. So this is how we have the bed 1, 2, 3 over here in this direction. And because this is down thrown direction, so bed 1 will be shifted. In this block we are not getting any of the trace or folder bed. So we can fill the symbol. This is our profile along line A dash B dash. So let's see how the profile looks like after filling the symbol. So this is your map. For bed 4 we have choose this color, and then bed 3 is represented by yellow. Since the profile is this one, we are going to fill the symbol within the profile only. This is our profile. Then we have bed number 2 that is represented by red color. So here we got the bed number 2. It's too thin in the profile. Then we have bed number 1, and that is represented by blue color. So here is our bed number 2. This unconformity will extend in this direction prior to erosion. And these beds are going to plot just below this the 2 is 100 feet. So here the bed number 2 in this block will come just below 100 feet from this unconformity. So here we will have bed number 1 and here we will have bed number 2. So 2 is over here in this block, just below. It is not coming over to the unconformity. Just below that we'll have bed number 1, and that is represented by green color, blue color. Let's fill this under as well. And all of the beds are there in the green. So this fault is offsetting unconformity as well. So this is a post unconformity fault. Let's fill this in. We already have interpreted the structure and topography. Now we will interpret the geological history once again. Before that, let's darken the profile in order to show you clearly how the beds look like. This is how the profile looks like, and this is how different beds appear. Right, so this is unconformity. This is down through direction, this is up through direction, and here we have 100 feet of through we have already determined in the last map, and we have fault like this. So we have first bed, we have second bed here. Well, let's fill the symbol for the second bed. And second bed of younger sequence has been colored by green color. So let's fill this green color. Prior to that, that has got some lines in it. Let's draw that as well. Second bed. First bed of younger sequence has not been given any color. So for section line along A dash B dash direction, we have a result now. So we have made two maps out of two section liner out of this map, the map number 13. So this was our first section line AB. So this is A, this is B. For AB line we have got this cross section, and for the line A dash B dash, that is along this direction, if we slice out the area, we are going to get the result like this. And here this fault was pre-unconformity fault in first case. This was not offsetting the younger sequence, but this fault over here is a post-unconformity fault which is affecting both younger and older sequence. So for AB section line, this is the cross section. For A dash B dash, this is the cross section. We have already interpreted the geological history, sequence of events, etc. So we will not repeat it. Let's revise the geological history quickly. So the bed 1 was deposited unconformably over unknown basement. Then this deposition was unconformable. Then there was conformable deposition of bed 2, 3 and 4. This was followed by upliftment and tilting and faulting. Then the area was exposed for significant time to develop this unconformity plane. Then the area was again submerged and there was deposition of like first and second of younger sequence, and the area again uplifted, and there was one more fault which affected both the younger and older sequence, and there was erosion to form the present landscape. Thank you.